All right. We are slightly behind schedule, but close enough. You guys ready to talk about some product development? Yeah. All right. Travis, do I need to wait for the internet? Oh, it's on. Oh, well, hello, internet. Okay, so welcome to our product development seminar. So this is going to be a little bit of a peek behind the curtain, how we decide what to work on, how we work on it, what we do, what that means, how the whole process goes. So as always, if you've seen any of the videos, if you have questions, ask them. If you're on the internet, go ahead and ask anything at any time. We have a filter person. If you're here, if it's on point, raise your hand, no worries. If you have a general question, we're gonna have a Q&A session at the end of it where I'll answer whatever questions you guys have. So, with that said, how do we decide what to work on? It's a pretty good question. So we basically take inspiration and ideas from everywhere. We have an internal form, so anyone in the company can say, hey, I think this is a good idea. We should work on that. Admittedly, that list is very long at this point. But we can go there, we'll take inspiration from our market, from other markets, from outside, from customers, all over the place, and then we have to filter that list. Okay, we've got a billion ideas, but is there a market for it? 2 people does not qualify as a market. There have to be enough people to justify working on it. Is it something that we can do competitively? We're not going to build something just to build something. We're going to build something because we can do it better. Now, better means different things. Better can be a more competitive price. It can be better performance. It can be better for this specific application, that kind of thing. So it really depends on what the product is, what the definition of better is, and if we feel like we can do it. And of course, does it match our ethos? Our aim is to help you have as much fun as possible in the driver's seat. If it doesn't do that, and sometimes it's the boring stuff like maintenance parts, but if it doesn't do that, doesn't fit our ethos, and we're not gonna pursue it. It's not something that we're looking to do. So sometimes we will evaluate things before the design process happens. Now, sometimes that's obvious stuff like data. We will look for fan kits. We'll look at airflow versus static pressure, because if your airflow is not correlated to a static pressure, it is completely imaginary. Check out all my other videos for that. So sometimes it's just strictly looking at numbers. Sometimes it's, can we actually do something better? So that's why we have this very odd contraption here. This is a project, we'll peek behind the curtain, what we're working on now. Please don't ask me when it will be available. It will be a while. But we want to do a shock tower brace for the NC. But we only want to do it if we can do it better. Now we can make it look all cool and fancy. That's not super complicated, which is good. We want to do that, but only if it actually functions better than the stock stuff. So how do we do that? We evaluate. How well does the stock stuff work? So we built this contraption. Please do not take out your knees on it. But basically this allows us to load the chassis and to twist the whole thing. Now this is not the complete setup, so please don't critique our setup. But jack stands and anchored to the ground and all that fun stuff in the real thing. This is just a easy representation, but basically we twist the whole chassis, we put the same amount of weight on a big lever arm, and we measure the deflection at the chassis. So we do that without the stock shock tower brace, and then we do it again with it to see what kind of change we get there. Okay, cool, it does make a difference. Yay Mazda, I'm not surprised. Can we do it better? How would we do it better? Let's just we're gonna experiment a little bit to see what happens. Maybe it's the fact that it's 3 pieces, which I get, but maybe the 3 pieces kind of hurts it a little bit. So let's weld them together and see what happens. Absolutely nothing, no change whatsoever. Okay, so what about a transverse bar? So we have this very, very pretty high dollar contraption here. You can see we started with a stock shock tower brace, and we welded it together, like I said, we tried that. And then we put a transverse bar. Okay, that made a bit of a difference. And then we put an X-brace in. Okay, that also made a difference. Cool. So now we have confidence that we can do it better by putting these things on there. So now it is worth pursuing that design and going down the rabbit hole of making actual parts and then testing those parts to see what kind of difference they make. Definitely do not ask me to close the hood when that is installed on the car. So once we decide we want to do a design, we have to establish goals. What are the goals? What is this thing going to do? Are there specific metrics? Is it a specific price point? What are we looking for? And can we do it for a reasonable price that people will pay? We can do just about anything, but you're not going to spend $5,000 for a shock tower brace. So we have to make something plausible and realistic. We also, most of our customers install things themselves. So it has to be as easy to install as possible. So that's a major consideration during the design process. So as we move forward, do the goals change? Do they need to change? Is there any kind of, a totally new goal, anything like that? So one of the things is the intake for the NC Turbo here. So originally we were trying to set it up so that we were using the bottom half of the stock airbox and the top, and we would use a custom top half. So we were going in that direction. Well, packaging became very clumsy. That would be, for our market and our volume, that would be a pretty expensive piece to produce. And it would compromise the cold side from the intercooler to the throttle body. So we decided that no, that wasn't a compromise that we were willing to make. So we changed that. We moved away from that goal, and we brought the airbox over here in the corner. And I'll actually talk a little bit more about that later. One of the other things one of our pretty dead set goals was using a stock battery for the NC Turbo. We didn't want to require something small, something expensive, something compromised, whatever. So that was the goal that we started off with. Now, what is required to meet that goal? So obviously we had to move the battery sideways, but then that meant that we had to move the power steering reservoir sideways, but that meant that there was some interference in there, so we had to make sure to account for that in the instructions. And all along the way, you have to think, okay, we have to make this compromise. Is it worth it? Is this something that is plausible for our customers? Is it something that's worthwhile to get the end result? And obviously we said, yes, it is in this case. And it's really pretty easy to install. It's not a big deal, but there are steps that you have to take. Now going to the installability thing, that's very clearly spelled out in the instructions. So there's no problem solving on your end. It's just follow these steps and bolt it in, type of thing. So another fun thing to consider in the design process is what are the best materials, what's the best manufacturing method for this particular thing. We'll do machining. We've just now started doing a little bit of injection molding, and this is all with our partners, not in-house. Casting, tubular stuff, whatever, there are a million different options for whatever it is, and sometimes it changes. One of the nice things is that we're using a fair amount of 3D printing in our production now. So you guys have probably seen the fleet of printers we have upstairs. They are running 24/7, and it has really opened up a lot of possibilities for us. So we're not a giant company. We don't do huge volumes. We don't buy things in thousands or tens of thousands or hundreds of thousands. If we buy things in hundreds, that's big. That's big for us. So point being, we can't really justify the price of injection molding. 3D printing allows us to effectively do that kind of thing, arguably better sometimes, at our volumes and at a realistic price point for our market. So stuff like the Randall here. So this is custom formed silicone from one of our suppliers, but it also has some 3D printed parts in there that quite frankly would never exist if 3D printing wasn't an option for us. Injection molding isn't really plausible for this. So it's very nice to have those capabilities and such. We also, little detail stuff, again, the NC Turbo, little bulkhead plates, we've got brackets and such, hold the map sensor in place on the NC Turbo. Anyway, just lots of little stuff that really works quite well. So we also need to make it easy to produce. Easy to produce means that it's going to be inexpensive or less expensive. It means that the supplier is less likely to have quality issues. It's more likely for the part to be right on the front end. So we'll do some things there, like the NC Turbo was obviously a big suck of the time recently, so it's a major focus here. But anyway, this battery bracket. So we worked with the supplier and said, hey, how much of this should we design in bends? How much of it should be separate pieces that get welded together? What's the easiest for you to do? So we work with the supplier to say, hey, given your capabilities, what is the best way to put this together? And that's why we ended up with the specific pieces that we did here, where there's separate pieces that are welded, but then also stuff that's bent together, like the contouring down here, both for fitment and safety. We'll talk about that more if you have questions. But anyway, that's all bent, because welding that would be really high effort. So we also try to use as many resources as we have. Now, sometimes that's reverse engineering because we need to just measure an upright and get it into CAD. We try to put as much into CAD as possible, because the more you can do digitally as a complete assembly, the more likely you are to have a good part on the very front end of it. So this is an example here. This is kind of an older one, but this is for our reroute. So we've got a scan of the back of the head. The very observant among you may notice that this is a BP4W engine and intake manifold with a cam angle sensor on it, which doesn't exist as far as Mazda is concerned, but we knew that was a possibility for our customers, so we wanted to put that kind of goofy combination in there to make sure that it fit with, that our design fit with that combination of parts. So we will also often work with suppliers to get CAD from them. So Willwood is a great example of that. So we work with them, they'll give us their CAD models of the calipers, and then we will digitally assemble that in CAD. So you can see we've got the stock upright, we've got the stock rotor, we've got the calipers here. So we'll just kind of constrain it, play with it, see where it needs to be, and then put it there, and then digitally build the bracket in between. Excuse me. And we will then print prototypes. So speaking of 3D printing, that's something we use a lot in the prototyping process. So we've actually been doing that for a long time. This is 20 years old? Actually, yeah, that's slightly depressing, but yes, this is about 20 years old. So this is very, very early 3D print from our NA and NB outlet. Actually, this reroute right here, these are a few of the different designs that we went through trying to figure out the best thing. And you guys are welcome to come up here and poke with this later. We've also, some projects require a lot of 3D prints. This is, actually it's definitely not all, but this is maybe most of the NC Turbo. Sometimes one specific design requires a lot of different versions. So the NC Turbo outlet, that goofy shape, oh man, that was a fun one. We went through multiple different manufacturing methods and designs. That one took a minute to figure out. Yeah, I'll just put that there. And then sometimes we use it in different ways, such as jigs. So machining the manifold, we actually had to do that one in-house for the prototypes. So we basically printed a reverse of the manifold to help fixture it better so that we could do that. Now, this is not a production thing, but for the two that we did here, it worked really well. So now once we get into the real parts, how does the design work? Do the goals need to change now? Could we do it better still? Could we do it simpler? Are we doing it in an overly complicated way? We need to reevaluate and make it with fewer pieces or easier to produce pieces or anything like that. So as we develop, as we iterate, we kind of discover new things. Like, for example, the NC Turbo, again, the airbox, we discovered through our instrumentation that we needed to decrease the intake air temps. So we put a lid on it, and that did it. But we initially thought that we would just need a baffle, and that was not true. The intake temps were pretty high, even though it's removed in that corner. So anyway, lid solved that, but we've discovered that through instrumentation and such. Oh no, it might be buried now. Well, over here somewhere, there is a map sensor. So basically the map sensor is kind of a headache to get in on the NC Turbo. So we made a bracket and we designed that bracket so that we could make the install as easy as possible. Yes, you will still call us names. I apologize, talk to Ford/Mazda. But we made it as easy as possible. And sometimes we discover other things like the turbo. We thought we had the turbo nailed down. We know what we wanted, which specific turbo we wanted to use. We start driving the car, like, wow, this thing spools very, very, very quickly. I bet we could use a bigger turbine housing and get some of the advantages that that has. So now we offer 2 different turbine housings for whatever your specific preferences are. Let's see here. Yeah, so more evaluation. We drive it a lot. We drive it on track, we drive it on street, we daily drive it, we cold start it, we do all that kind of stuff, depending on what the product is, of course. Is it going to be durable? We're looking for, OE level as close as we can get. So many tens, hundreds of thousands of miles, we want it to last that long, whatever it is. We also want, again, the install to be as easy as possible, so we have someone who's not the designer install it. And we have the customer support team, depending on the product, but we'll have the customer support team install it, partially for their familiarity, but also for their input. Hey, this was a pain, but this worked really well. This is kind of nature of the beast, but make sure that you write it in the instructions so our customers know to expect it, that type of thing. Yeah. And then frankly, it gets a little boring because we have to make it real. And that means paperwork and bills of materials and building the back end and all that stuff that is necessary and is actually a crucial part of making it smooth and is also not exciting. So we curate our catalog. We don't just throw everything at the wall to see what sticks. We evaluate different products and we pick the best product for that specific use. So now, a lot of times, that means we're building our own thing. So about half of our catalog is proprietary. But the other half, we will evaluate however it is, to whatever the goals are for that specific product. Is it up to our standards? Is the supply there? Are the instructions good enough? Does it match our ethos? Does it actually do what it says it does? We will evaluate it ourselves. We don't take people's word for it. Sorry, I kind of ran out of room, but up here, there is a bumper that has some fog lights in it, Morimoto fog lights, which we're now adding to the catalog because we have evaluated them and said, oh yeah, they work really well. There are these things that you need to know, so we're going to put that in the instructions, but they are actually a good product. Buried underneath here. Koni GTS for the NDs. Koni's a pretty safe bet. They should be good, but let's make sure. I don't want to just put them on the shelf because, yeah, Koni will be fine, no worries. And then it's not the best thing for our customers. So we've had a set of those on our ND3 for months now, driving it track, street, playing with sway bars, all that kind of stuff to make sure that it is actually as good as we think it is. Turns out the answer is yes, so you'll see those on our shelves shortly. But we didn't just take their word for it. That also helps us support things that much better because we have that much more familiarity with them. Now we are always trying to improve. You know, a lot of that comes from you. Hey, I had this issue with it. Oh, okay, yeah, thanks for that feedback. We'll get that on the list. We'll get that updated because that's a good idea. We really should have done that better, or we can move forward, make it better now, type of thing. Some of it's internal. Believe it or not, we use a lot of these parts. We have a very compelling employee purchase program to convince our employees to use the parts as well. So we get a lot of feedback internally as well, like, hey, this worked really well, this didn't work so well, that kind of thing. Now, again, continuous improvement. We've got some, apologies. So the Inconel studs for the NA and B turbo manifold. Now we had not a wild amount, but definitely some failures from the stainless studs, so we changed. Now we have, then this is standard on our NA and B turbo kits, so they're ARP Inconel studs, custom made, 2-hour specification, and now we don't have that problem anymore. We also learn from the things that we have done in the past. So for the NC turbo, the flange is horizontal instead of vertical, which means that we don't need to use those expensive studs because since it's horizontal, we just don't have that problem in the first place. So we can, because these are excellent and not cheap, so now we don't have to add that cost to the kit. The NA and B turbo manifold, we took a ton of weight out, the 24% improvement in efficiency, big improvement there. Talking about customer feedback, for the Hush can setup that works really well, and I'm happy to talk about, but the short version is the install required some splicing wires. That is terrifying for some people, and it can be a little clumsy with where you have to get into and all that. So we went from a splice-in setup to a plug-in setup. So, that's a plug-in harness. There's one wire that you have to splice in, and it's very easy. Maybe two, but anyway. And we made sure, it goes into your OBD2, it clips into place, it works very, very well, super easy to install. We also changed, I'm scared to get closer to the speaker, but we changed the crossflow radiator. So one of the bits of feedback that we got was that it was a little slow to fill. So we moved the filler neck from off of like a little neck to onto the tank. Now that required new brackets for the NB, but that's all solvable stuff. We did it. It's actually an even cleaner install, and it's more functional as well now. So another one of the kind of invisible things is just improving the engineering department as a whole. We've recently added a new member, Ryan, and we're constantly trying to improve our processes and how quickly we can put things through, but without compromising the quality of any of it. So now so kind of a combination of the two is our U-Design program. So just briefly, U-Design is basically if the crowd out here has a design for a part that is typically, but not always, 3D printed, we will evaluate it. It still goes through the same process, and if it's not a good fit, then sorry, I really appreciate your input. This is not going to be something that works for us. But if it does fit, or if it's close, then we'll work with the designer to improve it, to make it so it does match what we need to put it on our shelves. And then basically we'll put that on the shelves. The designer gets a royalty, we take care of everything, and the designer just gets a check as they sell. That is also a continuous improvement kind of thing that comes from the crowd. So this is a good example. The oil funnel, we've got these for all 4 gens. They thread straight into the valve cover. Well, now we have a cap. So if you don't want your oil filter or funnel to get any kind of dirt in it, awesome. So that's a continuous improvement thing that came from the market, came from our customer base. saying, hey, I did this, what do you think? Is it something that would fit? And we said, yeah, actually, that's a good idea. So we'll add it to our list. So that is the presentation. There's more in it, kept it kind of high level, but hopefully that gives you guys a good overview. Do you have any questions? Yes.
What filaments do you use for your final products? Are your printers fully automated? And I forgot the third one.
Okay, so what filaments do we use? We use nylon carbon fiber and PETG carbon fiber, depending on the application. Are our printers fully automated? I think the answer is probably no. We still run them manually, but there is a degree of automation in there, I suppose. How many members are in the development team? Kind of a loaded question, actually. So we have technically in product development, we have myself, Ryan, and Kyle. So I say it's a loaded question because everyone is in the development team, because we get feedback from everyone. A couple of months ago, we had actually a product familiarization day at the track where everybody was for the last 3 days, where we took all of our cars down, all the CS team and the engineering team just drove them and said, okay, partially for familiarization, but also, hey, this could be better if we did this. This could be better if we did that kind of thing. So like I said, we get input from everyone, including you guys. So.
But changes are made by development.
Oh yeah, changes are made by development. Yeah. Mm-hmm. Yeah.
Valved exhaust for the NC.
Valved exhaust for the NC. Stay tuned. So examples of products that got really far into the process, very exciting, and then didn't pan out? Yeah, actually. So, well, it was a long time ago at this point, but engine cooling on NAs and NBs has always been a thing, particularly on turbo cars. So a while ago, we went through a whole thing. Basically, I'll keep it brief, but the short version is we had a machine billet plate on the front of the engine that replaced the water pump. We had a specific reroute housing on the back. We had custom formed silicone hoses. We used an electric water pump with a controller on it that mounted in a place, doesn't matter. And it should have been amazing. It should have worked really well. And we put a handful of them out into the market, basically just 3 testers, 5 testers, something like that, and on our own car. And one person said this made no difference. One person said this is magical. And then on our own car, it was better, but it also would have been a very expensive setup. So we got pretty far down the road on that one, and it never came to fruition. So. Yes?
So when you have something like Pony and you're testing them out with your customers, you get feedback and you don't like them, or you like it, you send that back up. Do they respond?
Good question. So basically, if I can summarize, if we are evaluating an outside product and we don't like it, do we work with the manufacturer to improve it? Well, no. I was going to say we always do. That's not necessarily the case. But we often try to, and it's going to depend on who it is. Coney, they'll probably say, thanks for that. We're doing this anyway. But with other vendors, they're more likely, some are going to be more likely to take that input and to say, okay, we'll tweak it like this. A lot of times these are already on the market, kind of depends. That's a big part of it. But if they're already on the market, yeah, we'll put that on the next production run type of thing. So it really, very good question. It really varies on a case-by-case basis.
So you guys have been selling parts for all the generations for many different years. Do you have old parts where you're like, oh, that could be 3D printed. We should look into having a CAD model for it and basically changing the way that part is fabricated? Do you go through that process, and what does that look like?
So I think you said if there's an old mature product, but there's a new manufacturing method for exactly 3D, or for example, 3D printing, do we evaluate that? What does it look like? Is that, okay. Yeah, so absolutely. A really good example of that is our toolkit, which is on the grids over there. So they used to be machined aluminum pieces, which worked really well, but were a little on the pricey side. So now with 3D printing and with the material that we use, the printers that we have, that is an excellent option because now we can 3D print them for dramatically less money, so it makes it much more accessible to everyone to use on their own car. Now, how does the design change? Another excellent question. Machining is subtractive, right? You take a big chunk of metal and you remove metal from it until you get the shape that you want. 3D printing is additive. So you take air, just space, and then you add material to it in a specific shape to get what you want. So to make it as economical as possible, we tweaked the design so we only added the material that we needed. Whereas with machining, it would be, let's decrease the machine time to make it as inexpensive as possible. And if we end up with more material, then no worries, it was just gonna end up on the floor anyway. With 3D printing, we change it so that it uses as little material as possible.
Will you ever get into CNC and building your own redundant parts? Like something that would be...
Sure. So will we ever get into CNC and building our own parts in-house? Never say never. That said, we work with really good machining partners who have the volume and capacity to do it and to do it competitively and economically, and it's not our forte. So, you know, I have some experience with it in the past. I believe Ryan does, but we do what we do best, and then we let other people who are the best at that do that, if that makes sense.
I'm just wondering, my understanding is you don't do any metal 3D printing, and I wonder if you look into that, because I know it exists.
Sure. So the question is whether we do any metal 3D printing and whether we've looked into it. So yes, metal 3D printing is very expensive if you're doing it yourself. It's 6 figures pretty comfortably to get all the equipment. It's also slow, so it's not very good from a production standpoint, especially, you know, dollars for the machine. So the 3D printers that we have with the carbon fiber nylon and PETG, they are not cheap, but we're not talking 6 figures for those guys. So anyway, we will use metal printing as applicable in the prototyping process for specific things. For example, the NC Turbo outlet, once we had a shape that we were comfortable with, we wanted to put it on the car before we invested in the tooling to make a cast part. So we spent not a wild amount of money, but a few dollars on an outsourced 3D printed stainless steel outlet, or a few of them, so that we could bolt it on, run the car, make sure everything was good before we invested in all that tooling. Same thing with the manifold. The manifold was physically too big for any of the realistic metal printing. So that was cast per normal off of a 3D printed sand core, and then we did actually machine that one in-house, and then we had a couple of them that we could run without investing in tooling until we know that the part is actually good, that the design is good. Yes?
Do you see anything in the future for Flyin Miata being involved with either using or providing open source 3D printed parts? Does that make sense?
I think, yes. So question is, do we see FM being involved in open source 3D printing? So meaning you send us your file, we print it for you?
Well, either using open source parts as part of something you sell. Okay. And or, you know, taking something you designed and making that available as open source.
Okay. Will we provide our files for other people to print at home is at least part of that.
That's right, both ways.
Yeah, so unlikely. The problem with that is, my wife's favorite phrase, by the way. The problem with that is that we have no control over the printing process. So if we sell you a design and it says Flyin Miata on there and your print settings are completely wrong, what comes out is garbage, and your friend sees it and like, oh, FM has no idea what they're doing, that's terrible. We don't want, I'm not gonna pay any attention to them. So quality control is important here. We wanna make sure that everything that goes out the door is good. We're not perfect, we try. We have almost zero control over it in that situation. So for that reason, it is pretty unlikely. So have we ever used simulation, CFD, FEA, that kind of thing? So, okay, to back up, CFD is computational fluid dynamics. FEA is finite element analysis. CFD is, and actually I completely forgot one of my examples here, so thank you for that prompt. So the answer to that question is no. We don't do any of that in-house currently. Hopefully that will change. We do have to balance it with what the part is, what its use is, what the market is, what the retail price is. That stuff is all awesome and can get pretty expensive. So we have to be picky with where we use it. Now, FEA, actually that's not true. We did do FEA in-house recently on the hub stands to see if we changed some things on them. We wanted to see if we could increase the weight rating. The answer is no, so still 10,000 pounds per set. Or excuse me, 4,000 pounds, 1,000 pounds per corner. Don't put 10,000 pounds on it. So we did that to evaluate that to see what the safety margin was. For CFD, for the NANB turbo manifold, we outsourced that. So we said, hey, we have these hard points because we don't want to change. It has to work with all of our existing parts, but what does your CFD say the shape should be to be the best flow possible? And I won't go into the details because there's a whole video on that, so check that one out. But we did use it there. We also, this is another development evaluation kind of thing on this car. We're working with RGR Designs, who does do a lot of CFD, to develop multiple different parts. The new one on here right now is the flat under tray. So definitely come check that out. We have kind of tried that in the past, and the struggle is that we basically cooked everything in the transmission tunnel, including the things nearby, such as your feet. So Christian at RGR used CFD and our CAD models and his CAD models to put it together and run it to get air into the tunnel so that it would cool stuff off, but still be very smooth flow on the bottom. So that's something that we're currently evaluating now mostly for temperature stuff, and if the temps are in line, then we'll evaluate it for a performance standpoint. So we want to make sure it's safe, and then will it do what it's supposed to do performance-wise.
Make a lot of performance parts, but I don't see performance claims really as far as numbers and so forth. Is that a problem for manufacturers to have to want to spec legal reasons or whatever?
So basically, we don't provide performance numbers on a lot of our stuff. What's the 0 to 60 time on an NC turbo, for example? Well, if this person's driving with these tires and this elevation, it's this number. If that person's driving, it's double that number. So it basically, we quantify, if something, and we're trying to move more in this direction, but if something is objectively and repeatedly quantifiably quantifiable, I guess, then we will try to do that. If it's something that, okay, that person's 0 to 60 time is objective because that's exactly what it happened, what it was. But as a crowd, oh, well, my 0 to 60 time was 5.5 seconds, and you promised me 5 seconds, and now I'm upset. Well, so this person could do it, but that person can't. So anyway, we don't get into super specific stuff like that because there are too many variables, is really the short version.
Is there more development on quality of life parts?
Is there more development on quality of life parts?
Sound deadening kit for the NB.
Mm-hmm. So sound deadening kits for the NB, yeah, I mean, that's a good example. We have that. So that is quality of life. it's actually a really interesting conversation what performance means. Because performance could mean 0 to 60, it could mean lap time, it could mean higher performance sound deadening, so now I'm more comfortable in the cabin. So it's pretty broad. So yes, you can expect more of that long term. It's probably not going to be a major focus of ours, but it is something that we want to do more of, because that, kind of going back to the market, there is the market for that, and it fits our ethos of the most fun in the driver's seat. No more questions? Do we have internet questions? No internet questions? Okay. Yes? Do we do any post-processing on our 3D printed parts? Getting a little weedy, but the short version is, yeah, of course we remove supports, and that's mostly it. Sometimes we'll press in hardware, sometimes we'll put hardware in the middle of a print, but we're not doing like an acetone finish or anything like that. Yes?
How do you assess if there's a market for a part?
Good question. How do we assess if there's a market for a part? Frankly, a lot of it is subjective. And we look back historically, okay, we sold a bunch of these for the NB, so it's plausible that there would be a market for this for the NC, that kind of thing. A lot of it is talking to the CS team. Hey, what do you think about this? Have you heard noise looking for this thing? That type of thing. But there is some data that we can get from SEMA, but so we can kind of incorporate that in, but a lot of it is pretty subjective. And subjective, historical, same thing. Yeah? How do we anticipate developing products for the next generation of Miatas? The biggest thing to generate products or develop products for the next generation of Miata is improving the department as a whole. Expanding it, improving our processes, making it so that everything moves through as quickly and smoothly as possible so that we can work on things. We can prioritize what we're working on, we can get them done quickly, and we can move on to the next thing. Yep. Oh boy, that's a loaded question. So what kind of time frame do we have from conception to parts on the shelf? Well, there's a new part that Mike will talk about that Ryan literally had an hour and a half in. Now we still have to wait for production, so that's going to be probably a couple of months. So that's at one extreme, and the other extreme is something like the NC Turbo Kit, where it takes us a couple of years. So it really, really varies based on the product, and also that is one of the things that, improving the department, we want to make that as quick as possible. There's a limit to what we can do, of course, but we do want to make it so that everything flows through as quickly and smoothly as possible. Is actually all the questions this time? Okay, I'm going to call it. I think that's been long enough. If you guys have more questions, please come on up. You're welcome to look at this stuff, ask questions one-on-one. Thank you very much for your attention, and we'll have our next seminar in a bit.